this was interesting, right? We started like laying out the kind of like the storyline of how startups go from idea to minimum viable product, and we've seen live with Beanstalk how you can actually launch and go into production really quickly. We then had kind of like a break with some very good customers speaking about AWS, and Shekhar from Excel giving a very exciting story about not just how we helped Excel and its companies, but also how Excel sees the opportunity for the entrepreneurs in this part of the world. So now we go back to the storyline. So now you've got your minimum viable products in the market. Now it's all about scaling seamlessly and going global. So what you don't want if all these people come, when you get your Storied or TechCrunched or GigaOmed or whatever, and suddenly everyone comes, you don't want to see this, right? With AWS, none of that. You can actually scale seamlessly from 1 to thousands of instances and fully automate that. So the key question that I hear from a lot of customers is, all right, I have all these great building blocks, right? S3 and Beanstalk and all these beautiful acronyms. But how do I scale my architecture to support, let's say, my first 10 million users, right? So let's think a bit about that. And again, it was just mentioned 2 minutes before as if they've seen my slide, but it's all about thinking big, but then starting small. Start with your small little architecture that we've seen before. Your small architecture for your test dev, scale it out a bit for your alpha release, then go to your beta release, but ultimately you want to go into production. So this architecture that you can see here seamlessly scales to what we refer to today as your production 1.0 architecture, which is very similar as the previous one, with the only difference is it is now much more highly available because it's in multiple availability zones. We've explained the concept of multiple availability zones before, and when you go into production, we always advise to create high available applications and go multi-AZ. Now let's explore some of these concepts in here that we haven't touched upon, right? We've touched upon DNS already, we've touched upon the load balancer, we've not really touched upon the database side of things, and let's look a bit more into autoscaling because it's really powerful. First of all, database options, right? Now, with AWS, you have multiple database options. First of all, you can have self-managed options. You can run Mongo or Cassandra or Postgres or whatever on AWS. There's white papers available about best practice about how you can do that, and we really welcome any type of database on AWS on EC2. At the same time, there's managed databases that we offer. Amazon RDS from a SQL point of view, and DynamoDB from a NoSQL point of view. And I'll speak about both of those in a bit more detail later on. But the question we often get is, how do I choose what database technology I need? SQL or NoSQL? And what you see nowadays is that there's a lot of discussion around like our DynamoDB or Cassandra or Mongo or any of the NoSQL. So some folks won't like what I'm going to say now, but our advice is actually to start with SQL databases. And when you say that, normally you get people going like, but. No, seriously, it's best to start with SQL. And there's a couple of reasons for that, right? It's a really established and well-worn technology. There's a lot of existing books available, code, tool sets, and all that, and a very clear path to scalability. What's more important is that there's normally, unless there's like a really unique use case, that's maybe true for like 5% of you guys or 10% of you guys, but normally you're not going to break your SQL database in your first, let's say, 10 million users. So if you start with SQL, then one of the things we offer that's really powerful is Amazon RDS, which is kind of like database as a service without the need for all sorts of installation, database administration, very scalable and fault tolerant. Again, you can bring your own license, or you can leverage SQL Server or MySQL or Oracle that we offer as part of the service. It also offers all sorts of built-in features when it comes to backups, failover, and replication, and so on. Now, the other thing is autoscaling. And autoscaling, again, I think in a way is the essence of what the cloud can do in terms of its elastic nature. Now, Werner Vogels this morning showed about how that worked for Amazon. And he showed the peaks per day, and I think he showed the peaks in November when there's Black Monday and Black Friday and so on. And the importance of autoscaling. So let's look a bit at how that works, right? Let's look at this architecture that we've seen before. You got your DNS, your load balancer. In multiple availability zones, you have your instances set up. and you create an autoscaling group. Now, you have that autoscaling group, and let's say at some stage, your CPU utilization reaches about 80%. Let's say that that's the parameter that you've set. Your virtual servers, your EC2 instances go red, and it automatically invokes your auto-scaling policy that you can build into your AMI, and where you actually indicate what parameters need what action. We've seen before, we can do monitoring, alarms on that, and then set actions. And one of them actions is to say, when I hit X in terms of a parameter, what automatically happens is I build up additional instances and I auto-scale up. So I auto-scale up. Right now, I've got multiple instances that have come up. I can better deal with the load that I'm carrying. And if at some stage they cool off, the users go, it's late at night or whatever, it automatically scales down as well. Again, that has a massive impact on your scaling, also on your cost, and we'll talk about that later on. So with that, we now have kind of like tackled all the elements of this production 1.0 architecture. If you describe it, it's kind of like a best practice, well-designed two-tier architecture. It's highly available because it has multiple availability zones. Load balancing is there, auto-scaling is there, so you're very scalable by nature. Fully managed database included. And obviously, it depends on your applications and a lot of other factors. But typically, for a web app, a setup like this should be able to serve 10,000s, 100,000s of users. All good, but as you start scaling, you can actually start making improvements. With the architecture we've just shown, you have some wasted server capacity. If all your static content is basically on your instances, then that impacts the reliability and durability of that static content. There's also this concept in engineering called dry, don't repeat yourself. You don't want to repeat your static content on multiple instances, but rather you have one source. And finally, within this architecture, there's opportunities for actually improve the end user experience. So what do? We add a couple of services. We add simple storage servers, and I won't talk in more detail about it because it was addressed earlier in one of the demos. And we add CloudFront to basically optimize the end user experience. So CloudFront was mentioned earlier, but it's our worldwide content distribution network. It's really CDN the Amazon way, where there's no upfront cost, where there's fast integration, kind of like CDN as code, if you like, and very good for both static as well as dynamic content. If we put those into our architecture, you now see the same architecture as we have before, but at the right top corner there, you see S3 in front of it, and you see CloudFront as well. So let's call that our production 1.2 architecture. It has the same good things that the previous version had, but now my static content is stored in a very durable and consistent way, and I've improved end user experience through the CDN. One thing to note here as well is what you can start doing now is save your logs. When you do CloudFront, always save your logs. From a database point of view, save your logs. You have S3. I get a lot of startups that ask me, hey Peter, at what stage should we start like saving data? And my answer is always like yesterday or last year or 10 years back. The cost of storing stuff right now is so incredibly small that we always advise to store everything now, even if you don't have the means yet to analyze it. But later on, I'll talk about the importance of actually analytics. So start storing it now. Again, this architecture is really solid and should be able to scale up even further, maybe up to 1 million users. But again, you start scaling further, right? You grow your startup to your first 10 million users. So now you are at scale. You'll have lots of data. You constantly need to optimize. So how do you optimize? And where do you optimize? And where do you improve the end user experience? So what we'll do is we'll add big data for analytics of web, mobile, gaming, log data, as I just mentioned. Now, Werner this morning already showed that we have a range of services, EMR, Redshift, DynamoDB, a number of them. And let's zoom into 2 of them. First of all, DynamoDB. I just mentioned that it's always good to start with SQL, but what we see more and more, it's not like SQL or no SQL, it is all sorts of hybrid models. So we see a lot of gaming companies that have user credentials and so on in RDS, but session state data and certain other data in DynamoDB. Or at this stage, when you really get to scale, you might start really think about storing more data in DynamoDB, which is basically a provisioned throughput, NoSQL database. Zero admin, as we like to say. You can basically turn a switch and say how much IOPS you want from a read-write point of view, and it takes care of everything. Druva was mentioned earlier, and Druva is actually a very good customer from a Dynamo point of view. So they do a lot of storage. Now they store the data in S3, but the metadata per customer is actually going into Dynamo. So they moved from Cassandra to DynamoDB because they needed an engine that could do like 12,000 reads or writes per second, which is quite significant, right? And we've helped them, again, it was mentioned earlier by Excel partners, how we help customers with their architecture to save cost. We did that and helped them save a lot of cost and improve their performance as well. Now, the other thing is Elastic Mapreduce. So again, it was referred to earlier, but this is a really, really powerful service when it comes to providing analytics through a managed Elastic Hadoop cluster. There's a lot of people like running Hadoop on EC2, which you can do as well. But there's a lot of implementation, deployment, installation, and that's all complexity. So we offer that as a managed service that's really powerful, where you can still leverage your Hive and Pig scripts if you want. Anyone heard of Foursquare? Yeah? So Foursquare are very successful startups in the States, right? They founded in 2009, $112 million raised in venture capital. They have over 33 million users, a lot of businesses that use their services. And as you can imagine, they generate a lot of data. 3.5 billion check-ins, over 15 million venues, and terabytes of log data. They use EMR heavily. They evaluate new features. They have machine learning, exploratory analysis, more long-term trend analysis, a lot of things that they use EMR for. Again, they use it on data that they've stored earlier. So they store everything that happens on their site, they store everything in the database, they store everything that happens from a CloudFront point of view, and start analyzing that. And they generate clear benefits from that. Ease of use, right? Again, before you can do it all yourself with different building blocks and open source tools and so on, but with EMR, they've basically decreased the processing time for really urgent analytics. Flexibility is another thing. It's not like you just have to do like let's say every Friday or every Saturday run a job. What often happens is you need to do quick analytics for troubleshooting or for whatever reason, and you need to be flexible in terms of how you manage those analytics. And you don't want to worry about having fixed costs for that, but you want to, just like with your EC2 instances, you want to be able to be scalable when it comes to managing your cluster. Another thing is cost, obviously. They've reduced their analytics cost by about 50% by using EMR. So let's add that to our production environment. As you can see now, we still have the great environment that we had, but we've now added EMR right at the top. So I'm not sure whether you can read it, but within S3, there's two types of buckets now that you can see. One has the logs. As you can see, they come from the database or they can come from CloudFront. It goes into EMR, gets analyzed, and the results get stored in another bucket. So that's really powerful. So that kind of like brings us to our production 1.3 architecture. Still all the benefits we talked about before, but now we also have big data analytics built in for continuous optimization. So with an architecture like this, you should be able to serve millions and millions of users. It's really powerful. Now, obviously, there's a lot more you can do. There's more you can do on your database side, leveraging our, for example, Elasticache, our hosted Memcached offering, or you can start looking at more service-oriented architecture type features and look at loose coupling by leveraging other services from AWS like Simple Workflow or SQS or Simple Notification Servers or a whole lot of other things that you can do to further optimize. But for now, enough talk. Let's do a bit more of a demo. We're going to ask Ganesh to come on stage again one more time and specifically look at the auto-scaling as well as going global and CloudFront. So I'm going to hand over to Ganesh.
So I'm going to log in. Okay. And great. How do you like to scale this application that we developed in the afternoon? The application that we developed in 15 minutes, how do you think that's going to scale to handle the millions of users that Peter talked about. Will Elastic Beanstalk allow you to do that? Will it allow you to do that? We do have auto scaling there, right? So let us see that in action. So there are two ways that I can scale this application. I can either go and say, hey, I'll give my URL to like a bunch of friends and say, hey, you give it to a bunch of friends and let us see how much my applications can scale. Or use a pet project of Chicago Tribune. They wanted to test their scalability of their application. So they developed this product called Bees with Machine Guns on AWS. So they create multiple EC2 instances and give these EC2 instances machine guns so that they can go and hit your web server. Does it sound like attack? It is an attack. So please don't start tweeting saying that, hey, Ganesh has taught us how to do a DDoS. It is against a lot of policies, a lot of countries' laws to do an attack on a website. Okay, so let us use that to see how my application is going to scale as the user traffic increases. So what I've done is I've taken the liberty of, okay, I need you to raise your hands if you're able to see this. Okay. Okay, great. So I've taken the liberty of actually creating the bees. So I've already started the bees. I do not have much time here on the stage, so I started the bees. So let me show you the bees. The bees are running in the US East region. So I've got 10 bees running there. So each of these bees are going to hit my website 10 times till they hit 100,000 times. So each of them is going to go on hitting my web server. So I'm creating a load on my web server. So the other thing what I've done is I've also taken the liberty of creating another Beanstalk environment for this demo, which is right here, and that is my version. The same application, just running on a different application container. So what else have I made modifications here? I have also reduced my auto scaling properties to really low values so that we can quickly see this demo. Either I can keep it at optimal values and let it run through, and we can wait here for like another 10-15 minutes for the entire bees to come up and start hitting the instance, or reduce it and quickly see how the scale happens. So I've taken the later approach, and you don't want to do this in your production environment or even in your dev environment. So my auto scaling looks like this. So I've got 40 instances. I say from 1 to 40, scale from 1 instance all the way up to 40 instances. Have a cooldown of 30 seconds. If I've already scaled up, don't scale up or scale down for 30 seconds. Wait and watch what happens before you scale up or scale down again. I'm using the CPU utilization with an average threshold of greater than 25%. If my CPU utilization is over 25%, I will spin instances. When my CPU utilization comes below 10%, I will remove the instances. So let us quickly attack this web application. The web application, apart from running here, it is also running on my Route 53 URL demo.southpaws.in. I'm going to go to my instance, and then I'm going to attack demo.southpaws.in 100,000 times, 10 times in parallel. So they'll be reading 10 bees from the rooster. They're joining the swarm. There we go, bang, bang. We are firing away. So we are firing away at the rate of 10,000 rounds, one at a time. So I'm only using 10 requests at a time. So concurrently 10 requests at a time. You can modify this to suit your needs. You can say, hey, where does my actual application break? Even before it scales, can it break? Okay, there is a time to scale the application. So can it break even before it scales? So this gives you the ability to tweak this and find the breaking point of your application. So let us quickly go back to our Beanstalk application and see how the CPU is going to respond. So this is going to take some time. It's going to really realize that, hey, the load is increasing and the CloudWatch alarm kicks in and then an auto scaling policy is triggered which actually instantiates your instances and attaches them to the elastic load balancer. I'm going to show you all these pieces, but before that, let us see how we can take this application global. So we have this application, this is hosted out of the US West, Oregon region. I have people in Sydney accessing this application as well. So how do I take this application to people in Sydney? So I already have a S3 bucket where I have stored my static image, Bangalore.png. I've already stored this in an S3 bucket. So I need to make this available to my users in Sydney, in Europe, at a lower latency than what they would experience if they directly access this from Oregon, correct? So I need to go across the world to serve this file to them. If I make this file available at a closer location, then the end user experience will be better. Your users will be thrilled. To achieve that, we are going to use CloudFront, which is our content delivery network with over 40 point of presence across the world. So what I've done is, I have created a CloudFront distribution Are you able to see it? Great. So that's the distribution. The origin is my S3 bucket. So I'm telling CloudFront, whenever somebody comes and asks for files, go to this S3 bucket and cache it at a location closer to the user and serve it from there. Okay? So now let us, what we'll do is, we'll go back to our application that we created in Elastic Beanstalk. You remember our Summit 2013 application? So this application had S3 bucket as the image source. What I'm going to do now is I'm going to change the S3 bucket to the domain name of the CloudFront distribution I have created. Okay? So we go back to the index.php, update the image source made the change, git add, git commit, forward, CloudFront, and git aws.push, and my application is getting deployed. There we go. So environment update is starting. It is deploying the application. I've already got my version here, CloudFront 0.4. Now, I'm going to go back to my demo bees application to see what's happening to my CPU utilization on that instance. There we go. So bees are starting to attack that instance. I've taken a T1 micro, it's a very small instance type, and it's already touched the 100% CPU mark. So now let us go and see what is happening behind the scenes. If you look at the events, do you see that? It's added a new instance for me. So where has this instance been added? In the Oregon region, I have an instance now. See that coming up? So I have instances coming up. So these instances, as they come up, they have to clear the health check of the load balancer. The load balancer has to do a health check. And if they pass the health check, then they get attached to the load balancer. So I've got a load balancer here. This may not be my instance, load balancer. Okay, there we go. You see those instances coming up? You see them in service, out of service. So as they clear the health check is basically defined here as a TCP80, a ping target of TCP80. I ping the TCP80 port every 5 seconds at an interval of, so every 30 seconds, sorry, at a timeout of 5 seconds. If I don't receive a response back in 5 seconds, I mark the instance healthy if it consecutively fails for 5 times. And I mark the instance healthy if it consecutively passes for 3 times. So as the instance come up, they get attached to the load balancer, and the load balancer starts serving the traffic to these instances as well, like what Peter told. Your instances are running hot. As they become hotter, auto scaling will kick in and add more instances so that your instance can run cooler. So let us go back and look at our CPU utilization graph. Are you able to see that? As we keep adding instances, are you able to see the drop in CPU utilization? As we keep adding instances, the fleet that is running is reducing their CPU. They're running colder now. They're running warmer maybe. And as more instances are added, you will see that the CPU utilization comes down to 25%. And then once the bees stop working, the CPU utilization goes back to, your instances go back to the number of instances that you have defined as the minimum. So let us go back and see our CloudFront application, Summit 2013. So what is happening there? Wow, the application is up and running. There we go. This is now being served from the CloudFront Edge in Singapore. So let us go and see actually what happens here. So let us quickly open a incognito window, go to the developer tab, same like what we did last time, go to the network and call this. So that's getting served from a location closer to me. This way, you can take your application global and scale your application that you have built in 15 minutes and make it available to a global audience at scale.